Let's see if you can solve this Microsoft question. We are given n pairs of parentheses where we have to write a function to generate all combinations of well-formed parentheses. So in this case, given n is 3 and this is the output. Let's try and look at how we can solve this question. So whenever we are set to generate all the parentheses or all the possibilities, we should think about of how we can use backtracking and recursion. So when we are using backtracking and recursion, we possibly come across every possible combination that can be ever made. Let's try and solve this question. So n in this case is 3. So what all are the possible combinations of valid parentheses? First one would be the most intuitive one, that is this, and then the second one would be something like this. Third one would be just opposite of this, and the last one could be something like this. And that could be one more possibility in which it could be something like this. So these are all the possibilities of the valid parentheses that we see here. So what we'll do is, we see that whenever the size of this individual string is 2 times n, that is in this case n is 3. So whenever the size is 6, which is equal to 2n, we consider it as a full string. So whenever we are opening a bracket, there are two possibilities. We could either close it or we could open yet another parenthesis. So again we have two possibilities here. We can either open yet another parenthesis or we could just leave it as it is. Then here we have again two possibilities. So if we try to close this, then it will be an invalid parenthesis because there is 7. So this case is rejected. In this case we can see further. We can close this. So this is one of the valid parentheses. Same way, if you keep continuing to draw the tree, you will end up eventually having all the 5 possible combinations. This is one of the valid combinations. So what we have to do is, whenever we are opening a bracket, we'll have to put a closing bracket, and whenever the string is equal to 2n, the length is 2n, we have to stop. And one of the best possible solutions in this case would be backtracking using recursion. So let's try and let's look at the code. So we have the code here. Let's try and run this. So we see that all the test cases have passed. Let's quickly discuss what is the code. So this is the given function and we are using a helper function. So we are sending open and close. Open and close in this case is just an integer, which is just a count of how many parentheses we have open. If open is less than n, we'll keep opening more and more parentheses. And then if close is less than open, if the number of parentheses that have been closed are less than the number of parentheses that have been opened, we'll keep closing. Current is the current string length, and then we'll add on top of that, when we are opening one more, we are actually sending one more current, plus we are concatenating yet another open parentheses. Same case in close. When we are closing, we are incrementing close as well as we are concatenating a close parentheses. And I explained you how the tree works. So this is how we solve this question. If you did learn something new and you liked this, do consider to share and subscribe.